All right, guys, welcome back again to do a quick check-in on how far you're getting with the accreditation program. You've just done safety systems, and I appreciate that some of you will only be wanting to look at the residential systems like the ART system or the ART 15. And but having gone through the safety systems, I think South Africa, there's a real need for these niche commercial products, whether it's a fire door, security door, or a bullet-resistant door. Or fire elements. These are becoming items that the market is looking for, and there doesn't seem to be so much competition in that space. So it is a potential niche market for those of you who may look outside the residential space. Okay, so that was the safety systems. Then we're going to look at the two main building systems, the non-insulated steel building systems and the insulated building systems. I'm going to hand back to Andreas, but just to summarize, for South Africa, the likelihood is that most of you are going to be looking at the normal non-insulated building systems. And if you think South Africa, not long ago, we weren't using double glazing, and now double glazing has become common, even in residential homes. It's now common practice in the higher end. And so I believe that eventually the insulated framing systems or the building systems will also become insulated. So currently it's non-insulated, but the insulated systems, I believe, will become more common, and I think there's a need in the local market to be able to make those available and to have fabricators who know how to work with them. And Janssen has developed systems that are easy to work with, not only for the fire, because it's already got the ceramic core inside, but it's the same for the insulated systems. The thermal breaks are already inside. You fabricate it as if you were fabricating something which was not insulated. So it's not more complicated, or it's a little bit more complicated, but not significantly so. So we're going to be looking at those two systems, the non-insulated and the insulated, and we'll start off with the normal systems, the non-insulated systems, and I'll hand back to Andreas. Thanks.
Now are the non-insulated systems without the thermal break, economy 50 and 60 for doors, economy 50 for windows only, no doors. Also the families of ART 15 and ART system, and based on the economy family, folding and sliding doors. The difference between the two profiles, economy 50 and 60, is just the depth and of course the availability of different materials. Economy 50 comes in raw steel, zinc-coated steel, and the two stainless steel types. Economy 60, raw steel and zinc-coated steel. When it comes to the types of profiles, you will recognize that they are almost identical. The difference is the profile depth. And since on economy we cannot do doors, economy 60 we cannot do doors, we will be missing these profiles. The difference between a door, which you can construct based on economy 50 and 60, is the height, basically. The width is very close, 116 for economy 50 and 126 on economy 60. The height differs, 150 for economy 50 and roughly 3 meters for economy 60. Weight, the leaf weight on both systems is 230 kilos. So since we use the same hinges and the geometry is nearly identical, it's the same weight. Economy 60 and 50 can be equipped with the finger protection. We spoke about this when we spoke about the safety systems. Finger protection is especially popular in schools and kindergartens, or institutions, buildings where you have handicapped people, for example, where the risk exists that somebody can put his fingers between the moving parts of a heavy steel door. So how do we handle it? We reduce all possible gaps in the construction to either a gap below 8 millimeters or above 25 millimeters. This is what the norm says. The norms dictates basically these gaps. On economy 50, we do it using a ready profile. This is an integrated profile, so it replaces the standard profile on the economy. On economy 60, we take the standard profile and add a shell, an aluminum shell. It comes with a couple of accessories, the springs, the bolts, and so on, and also the gaskets between the round profile and the frame, the door frame. There is also another system which I mentioned already, and I don't know if it's being shown here. It will not probably be not shown. It's a fabric system. It's a attachment to the. You can use the standard profiles on both systems and attach a roll with a fabric rolled on it. So you have to imagine that the gap which exists, which is dangerous, is covered by a piece of fiber, and it extends as you close the door. It's not the ideal one. I recommend usually the half shells or the full round profile. This does a much better job. In addition, here we use pivot bearings instead of hinges, and this opens up a whole range of new possibilities when it comes to pivot doors. And I will show you a couple of examples. So this is still a description of the finger protection, and here you can see the bearing. Of course, they sit in the top and the bottom. The bottom one is the load carrying bearing, and the one on top is the guiding bearing, you could say. Here you see the dimensions of doors. The finger trap doors can be made in very similar sizes as the standard door. And you can, without the finger trap, do even more with the bearings alone. Here is an example from, this is a exhibition hall in Stuttgart, in Germany. So a large building, huge surfaces. And here the system, the Economy 50 system, offers the flexibility to connect large areas, large spaces into one or separate them. The doors are quite big, you see, over 360 and 2 meters width. This is possible with bearings. With bearings, you have a different, let's say, weight transmission to the structure, to the building structure. Hinges have their limitations. Bearings can take much more. The biggest doors we have ever produced here at Janssen or with Janssen systems have been based on the bearing system. And I'll show you some amazing examples of, of that.
Andreas, so I was asked recently if these particular doors in this picture you're showing us of the new Mesa, if they were automated or if they were manual.
I think they were manual. Here I don't see any electric openers or closers. I don't see them.
Okay.
So you've got to push them like this.
Yeah, I just said I didn't know, so I thought I'd ask the question. So it's not a big deal. Absolutely stunning, beautiful concourse.
They are quite easy to open. You know, the pivot bearings transfer the weight in a different way. You can open them with really one finger. It's a different weight distribution.
And I see these are the pivot bearing is in the center, so it should be even easier to open.
Correct. The more central you put the bearing, of course, the easier it is to open the door. Usually they are put maybe on at 1/3 of the distance from the edge to the center, but of course also like this you can do it. It depends on the function of the door. In this case, it's really just a separator. It's not a door.
Partition.
Exactly, partition. So if you have it as a door, and I think I have some examples later, then the position of the bearing is a little more towards the edge of the leaf.
Yeah, I saw many examples of these kind of what I call concourse doors in Australia and Southeast Asia, and I'd never seen them before. They're very, very nice.
Okay, so this would be an example of the position of the bearing closer to the frame. See, here it's not centrally, and this is a door, so this will make sense. This, by the way, is also I know it's either stainless steel. No, it's probably just zinc coated, left unpainted. The way I can tell. Yeah. Well, here is, for example, it's a good situation where stainless steel would be an interesting material if you work on the inside. Okay, so this is economy. This is thermally non-insulated systems, indoor applications, separator walls, partitions. Main uses, and of course doors. This is an example of a project in Amsterdam, the World Trade Center in Amsterdam, which was equipped with the Economy 50 doors, pivot doors, except here the architect was not really happy with the profile that we provided. As you can see here, on the outside, you will have the glass attached to the flange of the profile, and really this corner of the glass is unprotected. So a cleaning lady with the cleaning cart could easily just damage it and break the glass. So what we did for this project, we produced a new profile, added an additional flange here that protected the glass, and this was the profile that was used in the end. So it's very close to what we called structure glazing solution, where the glass is glued to the profile and you don't see any flanges, any profiles. It's just the glass and the silicone gap, which is visible. So this is the type of door that was produced here. Of course, in combination with pivot, you can do the sizes you want. This is the way to go when you want to create a lot of opening space.
Andreas, just something that I haven't figured out yet. Our front door for the showroom is similar to that. And what I haven't figured out is how they managed to mitigate water vapor in the gap, because I don't see any desiccant. Do you know if they fill it with argon, or do you know how they do it?
Good question. I can't tell you this.
Okay. It's something I want to try and figure out, because our front door is very nice, and certainly here we would have water vapor problems if it was just air, but inert gas like argon can work if you don't have desiccant, and then there's no desiccant holes in that door.
Okay, so desiccant holes are the drainage holes, yeah? You call them?
No, the desiccant is, like you would get if you bought a pair of shoes in the shop, they have a little sachet of salt on the salt, but it's desiccant. Silica, exactly. It basically absorbs water.
Yeah.
So in the double glazing inside your spacer bar, you have little holes drilled, and then the desiccant goes inside. It's actually, the other name for desiccant is molecular sieve, and the molecular sieve little beads go inside, and they attract any moisture that does come in, that gets through.
Yeah.
So I just wondered how it works with this, but it's not critical for the moment.
Okay, I will have to find out. I'll write down the question and.
Excellent.
Okay. Well, the way I understand this is on each, every leaf, you have to have drainage and okay, it's inside. Wait. You have to have ventilation in a leaf, right?
That can work.
You must have a circulation. On the outdoor applications, for example, doors, you will have drainage holes going out, or windows for that case, and up on top you have the ventilation openings. So you have a what would you call it? An equation of pressure. Yeah?
Circulation, yeah.
Exactly.
Or equalization.
So the condensated water can actually get out, and fresh air actually provides the pressure necessary to drain it. And the way I understand it, it is a must on any leaf and also on the facade. So I think it should also work. Your door is on the inside, yeah? It's a or is it an entrance door?
Yeah, but it's internal entrance.
Internal entrance.
But I think the pressure equalization systems, they work in a slightly different way to the drain systems. But in this case, I believe it works like a sealed insulated glazed unit, SIGU, or a double glazed unit. And I think the only ways that I'm aware of the double glazed unit works is either with an inert gas like argon or
these
with
silica.
Yeah.
I'll check this. I will ask our development how they solve this.
I'm not sure who made our front door, but that they would know. I don't know if it was your factory or if it was the Spanish or the Italians or somebody.
I'll try to figure it out. We will be with Reto in the afternoon. I mean, just in a moment. We'll ask him. Maybe he knows.
Perfect.
So. All right. Okay. So another example of what can be done with economy. But you're right. This is basically a double glazing glued to the profile.
Beautiful.
Arch profiles can be also produced. So economy you can bend pretty freely. The uninsulated profiles are of course easier to bend since you only have steel. As soon as the insulator comes into the game, it's a little more tricky, but we can still do it. Of course, the profiles most difficult to, or let's say the biggest challenge to bend profiles are the C4, the anisole C4 profiles. But we can still do it. It's still all doable. We've been bending profiles for 43 years now, and with good success. So there is some know-how in the company how to do it. All right, glazing beads for economy. There is different types. Steel glazing beads. This is the most popular or mostly used, most widely used system. It's a stud and let's say clip-on system. The shape of the glazing bead fits on the head of the screw of the stud. It's a self-drilling screw for standard materials, so standard steel, carbon steel, and it would be a self-tapping screw, not self-drilling, for the stainless steel system, which is also available. And then once you have set the studs, you clip on the glazing bead. It's a pretty fast and easy system to do. Disassembling is just as easy, screwdriver and take it out if you need to replace the glass. We also have the contour, angle contour steel glazing beads. These are the ones you see here. They're actually designed rather to produce a very slick views, narrow face views. As you can see from the geometry, they are not rectangular like the previous ones, but they are kind of flat. They do feature a chamber which you drill through, and this is how you fasten these glazing beads. So here you will have visible screws, but you will of course you will be able to use these this special geometry. To set the studs, to set these screws at the right place, we have a fastening set, which is a drill, an electric drill, and a screwdriver in one. You can just exchange the head, and you can drill and then set the screw on stainless, or just directly drill and set the screw. So drill and fasten with the self-drilling, self-tapping screws. This is an easy set to adjust. You adjust the distance between the edge of the profile and the center of the screw, which then goes through the which then goes through that opening here. Yeah. So this is the setting. The fixation set is well meant and designed to set these studs. The angle contour glazing beads, you basically just drill through. You mark a line and you drill it through. We also have aluminum glazing beads. So next to the steel glazing beads, the aluminum ones, also based on the stud system. Here also you set the stud and then you clip on the glazing bead. They come also in different shapes and sizes, so there is actually a lot of those. As you see here, the angled ones, the triangular ones, so you have a lot of possibilities here. For those glazing beads which you see here below in the last line or the lower line, these are not set or fastened with a stud, but rather with a spring, the fixing spring, which is then fixated with the screw. So this is how this system, these few aluminum glazing beads work. But from what I can say, they're not as widely used as the stud ones. The stud system is the main system. Okay?
I've seen that spring used on one or two of the showcase elements here. Is that actually like a continuous strip, or is that also just sections?
It's sections. It's these you could say, well, sheet metal, just formed sheet metal, bent sheet metal.
Okay.
So these are, I don't know how long they are, 3-4 centimeters maybe.
Yeah, it's tiny.
They're tiny. Yeah, they are tiny. They are tiny. Yeah. So
Okay.
usually the distance between the studs or the screws is 250 to 300 millimeters. So you don't need many of those. Unless you are in the RC class, RC, burglar resistance will require shorter distances, and partially depending on the class you are in, the higher the RC class, the more securing screws you would have to use. So sometimes you have to add some fixation points.
Okay.
Okay, so this is basically economy. Economy can be very, very versatile. As you saw, the pivot doors, standard doors, I didn't even show you. I mean, they're not really, let's say, exotic. This is just a standard indoor doors, single leaf or double leaf. What I would like to continue with is the ART system. This is a family of profiles developed or derived from the Economy 50, and they were designed to enhance the possibilities in inside room design and renovation. So they are even thinner than Economy, and they feature a lot more of these, you could say, vintage elements, like the vintage hinges, the olives, the handles, which are visible. So this is what this system features. Profiles, you can tell here, even thinner than Economy 50. They have a chamber, 10mm chamber. Economy has much wider chamber, a much larger chamber, and this is with this reduction to 10mm, we save a lot of phase view. The flanges still 20mm here to keep the glass in place. The total phase view is reduced by, I think, factor 2 compared to Economy. The ART system is a system or a profile system designed for windows, so you can make windows out of that, or door windows. So let's say a hybrid between a door and a window with the window handles. There is another system, another part of the ART system, which is called ART 15, and I will continue with that in a moment. And just to tell you this system or this set of profiles is meant to be used for producing doors. So in the ART family, we have the ART system and ART 15. With both, you can do doors and windows, and you can combine them between each other and also with Economy 50. So the non-insulated systems offer a lot of, you can say, even 3 profile families which can be combined with each other. This is the olives, well, handles, window handles. As you see, an older version, an older design, but this is especially what was the, let's say, the goal, the objective of this system, to cover these applications and the demands for this type of windows. France, Italy, they often ask for that. So there is a niche for that, a market niche, and we cover this. Most of all, the ART system is used, as you see here, for indoor design. Here, even used as a barrier between the inside and outside. We don't recommend it. These systems are not really thermally very well insulated, but as you see, they are used. France, Italy, southern European countries will use them also on the outside. But basically,
have they got drainage? They do. Eh?
They do have drainage, yes, but still the thermal values are just horrible. I mean, they are, I think, 5 or 6 watts. I mean, it's just. I mean, we don't even. I think they aren't even allowed in many countries to be used on the outside. You have to have a minimum.
In countries where the thermal values are not important yet, where energy efficiency is a non-issue and not legislated, it becomes a very nice system.
That's true. That's true. And of course, they have the right to exist also on the outside. As I said, if you don't have many differences in temperatures.
Just a question. We've got that historic door in our showroom, and you guys call it a window, not a door, because it's the ART system. But it is actually the size of a door, and it's probably used for a door. Is there a reason why it's called a window?
Yeah, because the fittings are not really door fittings. So we use the window fittings, like a balcony window, for example, and we call it a door. So per definition, this is a window, but it's used as a door.
Okay.
So that explains why. Yeah, in Germany or in German, you often combine. You take 2 words, put it together, and then you have a new a new definition, new word. So we use that for that window doors. Yeah. You can make a proper door. You can make a huge window, which is used as a door. We call it a window door. So
Okay.
that's a little bit the story behind it. Yeah. But Art15 offers full fittings for doors. So with Art15, you can make doors, fully fledged doors, and they will look just the same. I mean, there is no difference, no optical difference between Art System and Art15. Mm-hmm.
Yeah. Cool.
Mm-hmm. Okay, so there we are, Art15, and here you can recognize this. This is a brochure from the Netherlands, from ODS, Kluckner and Company. This is our partner in the Netherlands, and they take the initiative oftentimes and just experiment. And if the experiments are successful, they actually pass on the idea to us, and we oftentimes incorporate it as a standard solution. So this is how it happens, how it goes. Here you see they actually built a sliding door based on the Economy 15, which we don't do here at Janssen. It's not a standard solution, but they came up with it, and they cover it with the Art15 profiles. Mm-hmm. So doors, as I said, possible. You can. Hello. Are you guys still there?
Yeah,
you
are.
I'm
Okay.
just checking.
Okay.
I just turned off the video because we seem to be one slide behind, but maybe we're not. We didn't see the sliding door.
No, you didn't. Okay, it was just a part of the previous slide. Let me just go back.
I see. Okay, that's why. My mistake. So otherwise, fine. The cameras can go back on. No problem.
It's the one on the upper right corner. See?
Okay. Yeah.
That's it.
Cool.
Yeah, the Dutch like sliding doors a lot. I mean, there's been several intents to produce sliding doors with other systems, Arte, for example. Some were successful for projects. Some just did not fulfill the air tightness and the water tightness requirements. Because a slider, a slider slides. You have to have a brush gasket, and they are limited in performance.
I think what works the best seems to be the lift and slide gear.
Yeah, that's a different story. Of course, that's a different one. But we don't have it on Arte yet.
Yeah.
Okay, so Art15 doors, different combinations, fixed fields on the sides, so side lights, top lights, doors with locks. Here you see an example where you build basically a lock box. The profile itself is very narrow, very slim. So I don't know if there is a lock that fits in here without widening the box a little bit, but this can be done. I often see without, I mean, no locks, just roller latch locks, like here, like on the picture.
Yeah.
So these would be the typical examples. Art15 indoor design. This is it. So this is exactly what the system was meant for. Yeah, here are those two sides, a single leaf door. Here you see a wider profile that accommodates the lock. On the previous picture, they used the thinner profile. So here, sometimes you have to combine profiles as it's done here to accommodate the locks or the lock. For that reason, actually, you can also take profiles from Economy 50 and combine them with Art15. Okay. The depth is exactly the same. It's also 50 mm. Just the width is different. But if you cut the right angle, I mean, here it will be probably like 35 degrees. You can still make it look just like, from one system, one hand.
Brilliant.
So this is now the different threshold details. Look, you asked me about this. This would be a nice example of a almost barrier-free entry with the what is it, like a skirt gasket, whatever.
Yeah. So it's like a is it like a rubber?
Yeah. Yes, it's a rubber gasket here that ensures the tightness. But of course, it's limited. I mean, you can imagine it's not really perfect. The perfect solution is the H profile here on the bottom, two flanges on both sides, and in between the drop-down ceiling, or two. I mean, you can even do two. That's the perfect barrier for sound and air.
Okay.
Pivot doors also possible on the ART15. So if you want to go larger, you can do that as well. We've seen a lot of those, but here again, it makes sense to not to move the bearing much towards the center, but rather stay on the side. Folding doors also possible with ART15 economy, and for that matter also on Yanisol. So insulated doors can be built in this fashion. 1, 2, 5 leaves. That depends on the requirements of the customer. I've seen the biggest folding door I have seen based on economy was 5 and 5 doors sliding to the side, a total span of 15 meters, I think. So a separation of a room or a house from the terrace, or a restaurant from a terrace. This is the applications that we see here.
And the folding stacking, is the weather tightness reasonable?
Well, ART15 is not really meant for outdoor, so it would rather be the Yanisol. With Yanisol, you can make it really nice. You would be probably limited on tightness when it comes to ART15 and ART system.
Yeah. So we find in South Africa with the different regions, Joburg is less of a problem because they have less wind. They do have significant rain in the summer, but in Cape Town we have a wet, cold, very windy winter. And those storm rains are very difficult to manage.
How I can comment this? These, let's say, exotic solutions. We often do them in let's say, new markets, Latin America, the US, and Gary is the one who has most experience in these solutions. So if you have something like this, talk to him. He has a lot of examples how it has been done in the past, and things that you won't find in the catalog. So he's the right guy to talk to if you have needs for this type of doors. Just ask him. He'll have a series of examples for you guys.
Cool.
Okay, so pivot doors, ART15. Swing pivot doors as well possible. Well, it's actually pretty much the same. Here you have the bearings on the left-hand side, so it's just a bigger door. There you go. Opening like this.
That's beautiful.
It's huge, huh?
That's a lot of this office.
Yeah, with the arch stoplight.
So that's ART15. Wow.
Yeah.
So that pivot bearing must be very slim, at the top.
Yes, I don't even know what type of bearing they used here. It's not in the presentation.
Yeah, it's maybe a custom.
Yeah, it's probably done custom, and the bearing has been chosen, picked to the width. But then again, Gary will tell you where to find the right bearing and what is the one that they used on their project. Latin America has a lot of those. They love it. They love these huge openings. Yeah,
the thing is, the warmer climates generally lend itself with open plan buildings and homes.
Yeah.
So probably the south of France will be the same, I guess.
Yeah. Okay, this is an example of a planning of a door. This is a folding door on ART15. Just an example from a planning tool from ODS. So this is our Dutch partner who has provided us this animation here.
Oh, wow. Is this interfacing with SketchUp?
That I'm not sure. I don't know exactly. I'm not so much into software, so I don't know what other softwares are compatible with ours. But tomorrow you guys will be with Michael for the Yanisoft training. So he's the right guy to ask. He knows it in and out.
Well, this does look like SketchUp.
Does it?
The icons look familiar. That's quite cool. That's like an intelligent component.
I mean, you have
intelligent assembly.
Okay. Yeah, well, we have, and Michael will tell you more about this tomorrow. We have lots of planning possibilities and flexibility with Yanisoft itself, and maybe he will also touch upon the BIM BIM platform that we have? If not, just ask him for that, because this opens more possibilities. But with
yeah, this is seamless workflow. What's happening in front of our eyes.
okay.
But that's just real.
Chicken the millions. Made the millions.
That's just some guy that had some time on his hands, did a nice animation, and it's very much download 400 or ready for fabrication. I think that's just for visual.
Yeah.
Definitely it is. So.
Okay.
Yeah, but tomorrow, as I said, Michael will lead you into the Yanisoft and all its tricks and possibilities. Okay. All right. So, economy pivot doors, same story here, just based on the economy profile, so a bit wider profiles, possibility to accommodate the lock without building a lock box. This is what you can do. Folding, sliding. Yeah.
How does that work, Andreas? Where you take the lock block away, what do you do?
We'll say it again.
So when you take the lock block away, how do you accommodate it?
Well, here I can really tell how this is done. I see locks on both sides, so there is, I think, latches on both sides. I see.
They're kind of thickened up section.
Yeah, somehow I don't have details on this one.
Yeah, okay, all good. No, it's not important. It's fine.
I don't know if this is an additional profile that was welded on this, or is it the
for an architectural office, something different.
Yeah, but there is some modifications done here. I see also the glazing beads are not standard. Something was done here. Yeah, I apologize. I don't have all the details, the technical details on.
Cool. The questions are not important. They're just of interest.
Okay. All right. So pivot doors, gates, sliding and folding gates are also part of the portfolio. It's been done for let's say a firefighter station or a hospital entrance for emergency trucks and so on. So the possibilities are here. I go into the industrial area, I could say. We can use the heavy duty bearings for large doors, and well, you can build them. What is the biggest one? 5 meters at least, as a folding door based on Yanisol, for example. So there's been some industrial projects done, and again, if you have a request for that, then ask Gary. He's done it all. He's done much more than the catalog allows.
That's something that we hadn't considered at all. I'm not sure why I haven't seen it before, but that's quite interesting because it opens a new sector to us. Because there's two people that use this. One is the industrial, not as much because they need probably more security, and to beef up the glass can be quite expensive. But guys that own Ferraris and things in high-end housing, they love having the garages that you can actually see through.
Well, then yeah, I'm sure you have a lot of possibilities here. It is a little bit well, I wouldn't say a matter of improvisation, but you do have to do some steps that are not, let's say, catalog standard production steps.
With you.
But
and Andreas, is that the sliding rig or the head rig on top of that folding stacking door? Yeah. Is that a Janssen or is it a Hilalden product? So the bearings that hang on the top, to guide those.
We don't make them, that's for sure. We get them from someone. I don't know who is the supplier of these. I can't
allow them of units. Okay, again, not important. All good. Carry on.
Okay. Well, you got me. I mean, I have a certain level. The details. I'm just a trainer. I'm not a developer.
No, good. I can tell you that so far this is the best training I've had from Janssen. So okay. I've enjoyed it.
Thank you.
And I also enjoy your slides. They're very clean and professional. It's good.
Oh, thanks. Okay, so what actually summarizes or brings us all into one table is this graph here, where you see the economy 50 series, economy 60, and this would be the HI, the series 80, And here you can tell the width of the leaf and the height of the leaf. So of course, the bigger, the more massive the profile, the more you can do. And we have worked with all of them. So possibilities are there. When it comes to concrete projects, then again, Gary can support you guys, I'm sure.
Cool.
Okay. Folding gates. Yeah, different examples here. And this is a firefighter station in Germany. Folding gates. Again, this would be economy. Yeah, this is 5 doors and 5 leaves and very high leaves. Also a good example. This can be done on economy or a Yanisol. So both are possible. Actually, if economy 60 and Yanisol are the same profiles, have the same geometry. So here again for outside or inside application. Okay, so that's as much as I can show you for the non-insulated systems. Maybe to sum it up, indoor applications possibilities are vast, especially when the bearings come into the game. And here you saw a couple of examples. All right.